This is Saxon Advanced Math, Lesson 91, Geometric Progressions. Now, we need to review just for a moment what an arithmetic progression is. And we had a formula for that. It was AN, and this is our number of progression, right? Equals A1, that's our first, N is the number that we're looking for in the term, minus 1 times the D. D is the common difference. This is something we've already done extensively, and now we're going to build on that and say, what if instead of having a common difference, which is something that's being either added or subtracted to the first term, what if we wanted to use multiplication instead? And when we use multiplication, we would use it as a ratio. So in other words, if I said, if I wanted to double every single time, 2, 4, 8, 16, well, that's not arithmetic, that's geometric. And so we are going to use the term geometric to define when we have no longer a common difference, but a common ratio. And you could get any of those common ratios by taking any term and dividing it by the previous term. You end up with the common ratio. Now let's talk about well, we can jump right into our terms. If for instance, and the book uses little circles. I like to use the boxing method just because it makes more sense to me. If I said this is term 1, 2, 3, 4, 5, and I said I had a common ratio of -2, I would notice that I would say 8 becomes -16. I multiply by -2 again and get 32. Multiply as -2 again and get -64. Multiply by -2 again and get 128. Now, I want us to notice a couple of things. First of all, if your common ratio is a positive number, the means end up in between the to end terms. However, if the common ratio is a negative, it's going to flip back and forth. See, I've got 8 and 28, my first and my fifth term here. And these first and fifth terms that you notice, it goes, only 32 is actually in between my first and my fifth term. -16 is lower than 8, so it's not in between. So when we say means, we think of something in the middle. However, in geometric sequences, that's not always the case. If your common ratio is a negative number, it's not going to be in the middle. You're going to have every other that are in the middle, and it's going to flip back and forth. Now, let's look at example 91.1. Find the fifth term in the geometric sequence whose first term is -2 and whose common ratio is -3. Now, I like to actually put these in order like this, 1, 2, 3, 4, 5. And they said whose first term is -2, right? And then I would say, well, -2 times -3 is +6 times -3, -18 times -3, +54 times -3, -162. Now, what we're noticing on here is there's got to be an easier way to do this. We have a formula for the arithmetic sequence. Why don't we have a formula, therefore, for the geometric sequencing? And it's a good thing we do. Let's look at how that comes about. This fifth term is really using our common ratio of -3 how many times? Well, it's using it 4 times. If I wrote this out again, I would say it is -2 times 3 times 3 times 3 times 3. It's 4 times, which is 1 less than the number that we're dealing with. So when I look at this fifth term, I'm really saying it's -2 times -3 multiplied by itself 4 times. So I would say this is a 4 because that's how multiplied by itself 4 times. So A1 times my common ratio to the fourth would give me the fifth term. Well, how would I get that to always be 1 less? Well, I would say the number of term minus 1. 5 minus 1 is 4. So I can derive this formula. The AN, right, the number of the nth term is equal to the A1, that's our first term, right, times our common ratio brought to the power of n minus 1. N minus 1 is the number of terms, so it's always 1 less than the number of term that it's in. Let's look at example 91.2. Find 3 geometric means between 4 and 64. Now, once again, I like to write a diagram. I would suggest you write a diagram. I would strongly suggest you write the diagram because otherwise you get confused on how many terms are in the middle. I do it too. I want to know how many terms. So I say, if this is my first term, right? And I want to find 3 geometric sequences, so I skip blank, blank, blank. Those are my 3 geometric sequences, okay, means. And then I say, what's the last term of 64? So now I realize that really my fifth term is 64. So let me go over that again because that's confusing to some people. My first term is 4. I have 3 in the middle and then my 64. Therefore, my first and my fifth term are known. So I need to find out what the middle terms are, my means. Well, I really need to know what the common ratio is. That would make it more useful, right? So I look at it and I say, well, what is the common ratio? Well, A1 is 4, right? That's my first term. A5 is 64. If I use my formula, and I'm going to refer to this formula back because it saves me so much time. A to the n, or A nth power, or A to the nth term equal, I'm saying that wrong, the nth A is equal to A1 Rn minus 1. Well, 64 is my fifth term. So I'm going to say 64 is the nth term that I know, equals 4, that's my first term, my A1, R to the fourth. Well, where did I get this 4 here? That is n minus 1, so 5 minus 1, which is 4. So now I can very easily reduce this and say, well, divide both sides by 4 and get 16, right, equals R to the fourth. So the fourth root of 16 is going to be plus or minus 2. Okay, that's the first fourth root for those of you paying close attention. There are other answers that we don't get into here. But I say plus or minus 2 equals R, right? That's my common ratio. So I have two possibilities for this. I have actually a first and a second fourth term that I'm dealing with here that are real numbers. And I realize that this is, if I use the positive 2 times 4 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it works out for positive. But what if I use the negative version? And this is another possible answer for this one. And that would be, well, what if I put in a negative 2? And if I said negative 2, I'd say 4 times negative 2, which is negative 8, times negative 2, positive 16, times negative 2, negative 32, times negative 2 is positive 64. So there are two possible answer sets, and I'll have to be very careful when I take the root of this that I realize there's a plus and a minus version, right, a positive and a negative version that I can plug in. Now let's go ahead and move on to 91.3, and I'm doing all these examples because they get progressively more difficult, and I want to make sure we're understanding this. 91.3 says find two geometric means between 2 and 1/4. Now, once again, I start with my box. I say, there's my first term, I want 2 blanks, and my next term, and then I number them, 1, 2, 3, 4. So I know what this is going to look like, right? This is going to be my terms. Well, my formula, once again, A(n) equals A1 R to the n minus 1. So I'm going to say 1/4, right? This is the term I'm looking for, equals 2, first term, raised to the power, or R raised to the power of 4 minus 1, which is 3. Divide both sides by 2, and I end up with 1/8. 1/8 equals R cubed. So I take the cubic root of 8, and I am going to end up with 1/2. Now I don't have a negative version here because that would actually give me a negative 1/8. So I don't have two possible sets of answers. I only have one. And once I put this in, I say 1/2. So 2 times 1/2 is 1, times 1/2 is 1/2, times 1/2 is 1/4. And there I found the geometric means. And this has a positive only common ratio. The negative version doesn't mean anything because there isn't a negative cubic root of 8. It would be always a positive 8. It would yield us a 2. Look at 91.4. Find 3 geometric means between negative 16 and negative 1. Now, once again, I draw my box. Get in the habit of drawing your boxes. Negative 16 is the first term. I want 3 blanks and the negative 1. So now I know I have the first and the fifth term are known. I use my formula. There it is again. What's the fifth term's value? Negative 1. Negative 1 equals negative 16. R to the 5 minus 1, which is 4. Okay? I take the cubic root of both sides, and I get R is equal to plus or minus 1/2, right? The cubic root of, or the fourth root, not cubic root, but fourth root of 16 is 1/2. I have it as a plus or minus because either one worked, so I need to try it for both. And I went ahead and redrew my box down here so we could see it. The first term is going to be negative 16 either if I'm using positive or negative 1/2. The second term is negative 8 or a negative 1/2 times negative 16, which is a positive 8. And notice these are both sets of answers. Negative 4 and negative 4 are the same. Negative 2 and positive 2. Negative 1, negative 1. And both answer this original problem of the 3 geometric means. Once again, the geometric means do not have to be in between the two ends terms on geometric sequences, where they do always fall in that category on arithmetic sequences. So once again, with this lesson, the quick recap is that we have a formula for arithmetic progression, and now we have a formula for geometric progression. And when they ask you on a homework assignment or on a test, and they say use geometric, then you know you're using this formula. If you're saying arithmetic, you're using this one.